So that's the way it works, right? You introduce your boss, I introduce my boss, right? So Dr. LaPlante, who actually snuck in earlier while I was taking his place, so eventually 93 did clear up and he got here. Dr. LaPlante is currently the Senior Vice President and General Manager for MITRE's National Security Sector. In this role, in addition to managing me, he oversees the operation of 2 federally funded research and development centers, FFRDCs, the National Security Engineering Center, NSEC, which supports the U.S. DoD and the intelligence community, and the National Cybersecurity FFRDC, which is sponsored by the National Institute of Standards and Technology. As GM, Bill is accountable for increasing MITRE's strategic value across the company's DoD, intelligence, and cybersecurity portfolios. He previously served as VP in our intelligence portfolio. Bill has more than 30 years of experience in defense technology, most recently as the Assistant Secretary of Air Force for Acquisition. So we can blame him for acquisition. During 3 years in that position, Bill brought the $43 billion Air Force acquisition enterprise budget into alignment with the Air Force vision and strategy. Under his leadership, the Air Force reaped nearly $6 billion in should-cost savings. The investment of these savings resulted in greater capability for our nation's warfighters. In recognition of his outstanding performance, the Air Force Association awarded him the Stuart Symington Award for the most significant contribution by a civilian in the field of national defense. In November of 2015, the Air Force bestowed on him its Medal for Exceptional Civilian Service, the highest honor it bestows on a civilian employee. He's going to get embarrassed in a minute. And in 2016, the MIT Security Studies program presented him with the General James Doolittle Award in recognition of his contributions to U.S. air power. He holds a bachelor's degree in engineering physics from the University of Illinois, a master's degree in applied physics from Johns Hopkins University, and a doctorate in mechanical engineering from Catholic University of America. Ladies and gentlemen, please join me in welcoming Dr. Bill LaPlante.
Thanks. Yeah, it was almost as painful as being on 93 was listening to my bio. So it's okay. Hi, everybody. Good morning. You know, and the title of my talk, they put acquisition in there. But, you know, after this last panel, I'm not so sure I'm going to talk much about acquisition. I'm going to steal an NC3 joke that I heard from a 3-star in the Pentagon, and I'm going to apply it to acquisition reform. Sure, most acquisition reform meetings start out like a clown on fire. It's funny at first, but eventually it ends tragically. So that's why I'm not going to go too much into acquisition here, although I'm going to hit a few things. The other thing I want to do is, because of the excellent discussion that Fred gave and then the last panel, talking about history, and there's a lot to be learned from history. There's not repeating mistakes, you know, as they say, make the new mistakes, not old ones. But there's also the good news from history, whether it's World War II or as we just talked about, the missions that NASA did in the 90s and early 2000s. I want to add a couple things here that I would like to say about that mission that went and landed on the asteroid near. Number one, it was built by a UARC and designed by a UARC, APL, Johns Hopkins APL. I was actually there when they did it, another part of APL. By the way, 2 years after that, a guy by the name of Mike Griffin took over their space department. Okay, so I was built by a UARC, point one. Point two, this issue about not being able to land, that's true. So you know what they did? They circled the asteroid, and they said, the heck with it, and they just crashed it in the asteroid and got the last picture like 10 feet above the asteroid. It was fine. But the most important thing I'd like you to think about with that, and Dan Ward can write a book and tell me this is true or not. You know what was really focusing to that team of putting that system together, designing it and pushing off requirements? The launch window. The joke was if they missed the launch window, they just had to wait 350 years due to Keplerian orbits and the next asteroid. It's funny how when you have something like that that focuses everybody, as they say, from the janitor all the way up to the project manager, how you get it done. So these are lessons that we can learn. Another thing to think about, and I don't know what to make of this, when Fred brought up the Liberty ships and the B-17, I went back on and I thought about it, and I did a little bit of reading to something that I think is true. A lot of those systems, at least those two examples, the Liberty ship and the B-17, were actually designed before Pearl Harbor. They were. In fact, now I don't know that, I haven't personally proven this, but I've heard this from industrial experts that say almost all of the key systems in World War II that won the war were designed before Pearl Harbor. There's a few exceptions. So what does that tell you? It tells you production's part of it. Production happened during the war, but you got to be doing the designs. You got to be doing designs now. Okay, so we are in a different era right now. So I was going to talk about the why and then the what. I think this audience knows the why. It's not been that long ago, 2014, we were still debating, some were still debating in the Pentagon and at the White House and on the Hill, whether space was a global commons. It was a debate. We've come a long way since 2014. Now we're in this period of time, as Harvey Sapolsky, who's a former professor emeritus at MIT Strategic Studies, he's written about the history of acquisition, great books on the Polaris program. And he writes that we go through phases in our country in security. We go phases of peacetime, where people look back and they say, why did we spend so much money? They look at the scandals. They look at perhaps even, spare parts. There's always spare parts that cost too much. And then we have security panics, he calls it. I don't know that we're in a security panic now, but we're in a security high concern. Anybody who in this room knows, if you actually look at what's going on in space, you don't even have all the highest clearances. It's a bad situation. It is not a good situation. And the American public, as we often say, still does not know that. And that part of it is that that's a challenge of people like Fred and Mike Griffin and others to explain to the Congress and the American public the situation we're in without spooking everybody. One of the reasons I think Mike has gone really public on the hypersonic threat was because it wasn't being talked about. Okay, and so this is part of the era that we're in. Now, as Harvey Sapolsky says, when you're in an era of security, he calls it panic, you do things a certain way. This is our history. History doesn't repeat itself, but it rhymes. You relax the rules. You accept things like concurrency. You may not be done with the design. You go into production. And things will happen. That's where we are right now. And when you're not in the panic, that's when you start looking at the scandals. That's when you start putting in oversight. That's when you start centralizing everything. So right now, we're in a period of time, we're in a security rush. So I would encourage everybody in this room, we've had an influx of money to this community. We've got an influx of attention. As Fred said, let's make the most of this right now and make the smartest decisions we can make while going fast. So let me talk a little then about the opportunity. The coin of the realm is proliferated LEO. I think it's, as you all know in this room, it's much more complicated than that. Proliferation by itself, as Fred pointed out and others, is the resilient concept. The LEO could be MEO, could be a hybrid, depends on the mission. We'll tell them about that in a second. The whole inherent idea is the production line itself. The hot production lines, which we don't have right now, is the deterrent, is the resiliency. Okay, that's the key thing. But think about it for a second. Having a hot production line means you better have a design. Okay, remember the thing about World War II? They got hot production lines for the Liberty ships, but they had designs. So that's what we need to get on with right now, are the designs, which leads to my next point. You know, there's the old saying of the golden school buses, that's what people call it, you know, in the sky. We build these golden school buses that are big targets, AEHF, you know, that kind of thing. We all know that. We all seen it. And let's at least do a little bit of diagnostics on how we ended up there. And I will just give you my summary of, as I've looked at the history. It has to do with requirements, boring requirements. And because you have to decide what you're trying to do in space. Sounds obvious. We don't have this discussion enough. Fred touched about this. I'm going to list five sort of missions. PNT, you know, GPS if you want to call it that. Missile warning, like the SBIRS, OPIR, that's missile warning. Missile defense, different mission. Different mission. Comms, whether comms is tactical comms or it's things all the way up to nuclear command and control. And then, of course, you have ISR and everything that means, including to the intelligence community. So the real question now, as we're running fast, as we're getting this money, as we're doing the designs, as we're looking at proliferated things, is what are we going to design to? what architectures we're going to do. The system in the past, let's get back to the near example, the asteroid. In the past, what the system did was take one requirement and add on to it others. AEHF was supposed to be for NC3, which is relatively low data rate. That's not what AEHF became. It's not what the terminals became. The FABT terminals became $10, $15 million terminals, which we'd had to terminate the program. Well, why'd that happen? Well, it happened because the process was going along. We were going to do, and this is before my time, going to do the NC3 for AEHF. But then we said, well, we also need to do comms on the move in the Middle East for the Army. We got to do this other thing. And all of a sudden, you're building the Golden School Bus. Okay, that's what we can't do. So we have to decide, of those 5 missions, are we going to have one architecture per mission? Are we going to combine missions per architecture? And how do we do that intelligently? And we tend to go the Swiss Army knife approach, which ends up with these massive systems, when we might just use a plastic knife, fork, and spoon. But that question needs to be answered. You know, it's not just the rush to proliferated constellations. The question needs to be answered is, which mission or missions are you going to do? Those are not, it's not easy to figure that out. So I just would remind people about that. Let's talk about what needs to happen. What are the key things? You got the missions and you got the architectures. There isn't going to be one architecture. As somebody said it earlier, there isn't. So when you take those missions, you got to look at what the architectures are. We all know that. We've tended to, for lots of the same reasons I said before, we tend to keep building the same architectures. That's the one thing that's changed now, is we're now, no kidding, going to do different architectures. This is the biggest thing that will change the culture, is the fact that we're going to proliferation. It's been talked about for years. Willie Shelton used to talk about disaggregation all the time. But the building kept coming back with the same old architectures when they did their AOAs. We've broken that. We've got the leadership in place now to push forward and do this for the first time. This is a big, big deal. And it's an aside, I want to say something about AOAs. Let's stop them. Or teach them to the Chinese. So, in the spirit of being a little bit of a nag, we can't forget about the ground segment. You know, the ground control of the satellites. So when we're thinking about these constellations and these proliferated things, what's going to control them from the ground? We got to think about that. And then, of course, you have to think about receivers. And we'll come back to that in a second. That's another mistake that we got to keep making, is we get one part of it right, and then we screw up the ground system, or we screw up the receivers. Let's not make that mistake again. Let's make a new mistake. Okay. So a couple other things I wanted to point out to you all to think about this with proliferated LEO and where we're headed, or proliferated anything where we're headed. Number one is, as Fred was talking, I was thinking, you know, we still do some things that are proliferated in terms of production. I mean, we don't call it that, but munitions, precision-guided munitions. We produce hundreds, thousands of them a year. When we did the counter-ISIL fight, when I was at its height, when I was serving, we had to turn those production lines up really hot. So we already had the designs done, but you had to turn the production lines up. What did we learn during that time, which I think could apply to this situation? If we do get these hot production lines, number one, you learn there is a minimal sustainable rate. Okay, for you to get learning, you've got to keep producing. It's sort of where F-35 is right now. For them to keep bringing the price down, they got to keep producing to get the learning up. Which leads to the second thing we've learned from munitions. The budgeteers love to take the money because it's then your money. Or it's because it's easy to take the money. You know, that's one of the few good things about long, big programs is when you're in development, you can keep the budgeteers away from you. But when you're buying stuff in 1 year, it's easy for them to take the money. So that's also got to be protected as we get into these productions. The other piece that we've learned from our munitions is quality. You know, I'm sure you would all know the things that should be able to be routine or were done 10 years before by this contractor. All of a sudden they've discovered they can't do it because a sub to a sub was bought out and they lost quality. So you have to pay attention to the quality on these production lines. All of that is mitigated, all of it, by keeping the running hot. As long as we keep it hot, keep the budgeteers away from it, be above a certain minimal sustainable rate, I think this is something we can really do. The other thing to think about is the services model. It came up earlier. As you guys all know, we launch our most precious satellites as a service. As I always say, you know, if SpaceX paints on the side of their Falcon 9, I love Elon Musk, Air Force is fine as long as it's certified because it's his rocket. Okay? There's some real goodness in doing a service. So what about in the future, maybe even not too much future, having a consortium, this is not a new idea, that would do proliferated LEO as a service. Say all you got to do is keep that thing going, keep it up, send up a 40 every year, and the government will pay for it. Okay, so this is the kind of situation we should be looking at as we go to this new model. It's a fundamental game changer by going to this proliferated construct. But again, we got to think about the ground systems. Okay, let me change. Let me add a few other things that I think are really opportunities. Yes, I drank the Kool-Aid on all the modern software DevOps because of the DSB study we did a couple years ago. I'd heard all the same things, you know, oh, Silicon Valley's much better than you guys. You guys are in the dark ages with software. It was true. We went out to Silicon Valley and saw that. You know, and now you see with Kessel Run and everything else, there's a lot of movement to change that. Well, I think there's something else that's happening out there that we can really exploit that's right under our nose, which is digital design. And the idea is that we have design tools today that are being used by industry, including our auto manufacturers, that we didn't even have 15 years ago. In fact, I was on a task force that was just out at GM and Ford the week before last. And I was many of us are blown away because they're doing less prototypes, like for the hybrids, the electric hybrids, they're doing fewer prototypes rather than more prototypes because they can do so much with their computer designs. In fact, they can iterate, crunching thousands, millions, you know, and potentially millions of even data points on the design of a propulsion for electric hybrid vehicle. There's no reason we shouldn't be crunching those kind of things on the designs of our satellites. Okay, instead of, I mean, it actually, for them, they actually say we're saving money by not prototyping. So this is a change. It's a change that's hitting I mean, why are they doing it? Because they have to. Just like why did software development go fast? Because you had to or you were out of business. So I think this community may actually have something to learn, not just from Silicon Valley, but from the auto manufacturers, believe it or not. So there's some real opportunities now to get this going, but we only have a few years. We only have a few years. And so I would encourage this room really to get rally behind this. Help us answer the questions: what architectures, what missions, what's the ACT strategies, services, not services, and let's get on with it and get these things fielded. Final comment I'm going to make, and then open up for questions, is about PNT. I have to be a nag about PNT. GPS. Okay, you all know it's ubiquitous in our life, yada, yada, yada. We all heard the speeches and stuff. There's a Ken Gabriel's the head of Draper. He always pulls out his phone and says, you can listen to the first, what was it, Sputnik going around the earth, you know, as the Onion said, small steel ball scares the hell out of America, that kind of thing. We all know those stories about GPS. We know the situation today, though, with GPS is concerning. Not just the dependency on it in our military and our civilian life. Of course, we all know it's for timing as well. Everybody's using GPS for timing. We don't even know who's using GPS for timing. More so even than position. So you say, what's the problem, Bill? Well, I'm not going to talk about the vulnerability of GPS. The actual GPS M code that has been going up now, we're just beginning to launch the GPS 3, right? We just launched, I think, the first one last December, I think. M code is really a pretty good thing. It's the closest thing we've got to a very, very resilient, hard to jam, hard to interfere with waveform. And when we get the receivers out and get the satellites all with M code, it's quite capable. It is your A280 PNT capability, albeit against certain types of threats, we have to have something else. That's why we know that, right? Because it still is a satellite constellation. Therefore, it's vulnerable. Here's the issue, though. Again, let's make new mistakes. You know about the ground control station for GPS. Sandra's written about it many times. OCX. I won't even go into that. But here's the thing. you know, the M code requires the receivers through all, think of the DoD, all of our weapon systems. The Army probably has tens of thousands of receivers they need. The concern that I have is if we don't change something, the forces are not going to be equipped with those receivers until about 2040 in any degree of numbers. If that surprises you, it should. So we've got the satellites going up now. We're fixing this ground control station, even though it's $6 billion over. Hopefully it'll get fixed. But we have not budgeted in a timely way to get the M code receivers out into the Air Force, the Army, the Navy. And there's lots of reasons for it, including the MGUE program. So I do want to remind you, let's not do something like that again. And what happens is people, at least in the Pentagon, you forget. You focus on the GPS-3 satellite. You may focus on the ground system, but somebody just assumes that everybody's going to have the receivers. There's actually a special program called MGUE to build a prototype first 1 to 2,000 of those receivers, and the plan is to then have commercial entities come in, take their designs, get them validated for security, and then the services fund these providers, and then we start putting out M code. The way it's going to happen now, it may not happen in 2040. So I want to call attention to that and remind everybody, it's not just about the satellites in space. The other piece, of course, is the launch itself. We have to, you know, we still have only 2 providers of launch. We still only have 2. One of them has a Russian engine on it. Okay. Now we've made a lot of progress in the last few years, but we still aren't there yet. And so the other thing to think about, if we go to these other kind of constellations, you can get rid of the tyranny of having only those 2 providers if you don't need them. You might not even have to only launch out of the Cape or out of Vandenberg. That's where we need to go. So why don't I stop at this point and then open it up for any questions? Yeah, hi, Sandra.
Thank you, Bill. I wanted to pick up on your last point about launch. I mean, you say we only have 2 launch providers, and then you can free yourself from the tyranny by going to these new providers. But can you explain what you mean by that? Because these small launch vehicles, new players, they can't launch the satellites that DoD and the intelligence community requires. I mean, this is a very complicated process to become a certified national security launch provider. So how do you envision that you can get from A to B, like what you talked about?
Yeah, thank you, Sandra. Yeah, so the question, of course, is, you know, if we have these exquisite satellites that go to orbits and have a payload and throw weight that can be done by these, right now, only 2 companies with their certification. I think the whole idea, and Fred alluded to it in his talk, is if we're willing to build satellites that are smaller, that we have hot production lines, we may have much more relaxed certification requirements, because losing 1 in the drink out of 10 may be okay. And it's a totally different mindset. I often used to think how much the satellites we were building was driving our launch situation into these 2 people. The thing I'd always tell people, they would think, well, gosh, commercial launch, space launch, that's going to explode around the world, right? And I to Sandra's point, I used to always say, yeah, for everybody else, but not for what we have. So the point is, if we change what we're launching, then we're not dependent on only those orbits, only those payloads. If we're much smaller, I mean, I think that the idea for someone like Fred is never have to use those guys, potentially. You know, that's the thing. I've had this discussion with Mike Griffin a lot, where, you know, if we had gone to these proliferated constellations 10, 15 years ago, we would be in a very different situation with space launch. So they're all interrelated, you know, and they're all interrelated. And you have to remind yourself that for the stuff we launch now, particularly for, let's say, an NRO type launch, the launch is, people focus on the cost of the launch. The launch is probably 10% of the payload, maybe even less than that. The payload is a lot of money. And so that's what we're trying to move away from. Go to the droid, as Dan Ward would say. Get away from Battlestar Galactica, if that answers it. Yeah. Other questions? Yeah, right here.
Mike. I'm Graham Paradox. Look, you mentioned this the ground element. MGE is an example. Thank you. I'm fascinated by this because it seems that when we look at the word enterprise is getting a lot of traction. We need to work as an enterprise, and as we adopt commercial solutions, each with their own business case and their own enterprise solution, it may likely be purposefully built so as to be not integratable or easily integrated with other commercials. So it seems like one of our key challenges is how do we recognize that we are going to forever be in a hybrid, heterogeneous architectural place, and then allow emergent technologies and implementation to happen very quickly in a very heterogeneous environment without having to have a warfighter. Well, I don't have one of those, or I've got one of these. Only things that connect with this work. So that's cool, but I can't really use it. Or now I've got 4 different things. Now I, the warrior, am the integrator myself. So is there a place for integrators? Is there a means to, is there a technology solution that says, I no longer have to care about the heterogeneous nature of the ground. In fact, I love it because it adds diversity. It frustrates an adversary's ability to defeat me when I integrate into one singular answer, then I've lost, and I may not even know.
Yeah, it's a great question, because when you always have to ask the question whenever you hear these concepts out there, you say, do you need an integrator, and who is it? Is it the government? Are you going to have? I think that I'll speak just for myself, but I would defer you to people like Fred and others. Let me tell you the idea. The idea is simple. It's not, but to do it is hard. The idea is if you can get industry either on their own or by our encouragement to agree upon interfaces and standards, APIs, whatever you want to call it. In fact, it's best if it comes from industry, not imposed by the government. That's the best of all worlds. Then you could imagine a situation where you could plug and play these things pretty easily, and maybe you don't need a big integrator. I think that's the hope. The hope is that as these commercial guys emerge, that there will be agreed upon standards. Now, the government we have some ways to enforce that. We did that on Bomber. We took the OMS standard, which was developed by a consortium of industry, and we said to both, in this case, it was Lockheed and Boeing on one team, and on the other, Northrop. We said, we don't care what you do, but if you got to build your system to this OMS standard, all the interfaces. And of course, they had to do it. In fact, during the source selection, they started doing PR stunts showing everybody how they loved OMS. They didn't love it before, but they did that then. So if you put it in the RFP and you say you're going to do it, they'll do it. But ideally, what you want is you want them to agree upon those interfaces and those standards. Another piece I want to mention because of the question, and this is something I always used to struggle with. When you're in the government and you're looking at these things happening in the commercial world that are exciting, you're still having to do either informal or formal business case analysis of what they're doing. Are they going to be in business in a year? Are they going to succeed or not? And that's one of the hardest things in our business when we're trying to leverage commercial. Because I use the analogy, or maybe it's not even an analogy, it's just a story of the 90s. You guys remember back in the 90s, I was a young group engineer at APL, and we were putting L-band antennas on everything. We were putting them on submarine Boeing cable. We were putting them on ships, even at that time, UAVs. Why? GPS was just becoming ubiquitous, but the other was because they were going to have all these LEO constellations we're going to hit. We're going to have the sun blotted out by iridium, and remember all that? Didn't happen because the market went in a different place. So that's the piece of this that we all have to watch very carefully. And when you're in Fred's position or Mike Griffin's position or JT Thompson, you're constantly having to look and say, are they going to, what's their business case? Where are they going to make their money? And if I tilt my enterprise towards where I think they're going to make their money and get their production lines hot, what risk am I going into? I think getting back to something Dan said about a portfolio approach really is wise in that regard. So there's always surprises, right? No, the venture capitalists are not always right. Companies fail, and we don't know where the markets are going to go. So you have to keep your eye on the business case, and that's something I think that's also important. And I know it used to keep me up at night. I was always trying to figure out SpaceX and ULA's business case, because if I could figure it out, then I knew whether to worry or not. So there was another question back here. Yeah.
This morning, we've developed this idea that the resilient, proliferated LEO is the analog to victory, that the B-17 and the victory ships provided, or actually Liberty ships provided in World War II. The B-17s, tremendous losses until the P-51. The Liberty ships, tremendous losses until anti-submarine warfare. Who is staying ahead and how are they approaching it? That proliferated LEO is probably not going to be enough. What else do we need to be thinking about?
It's not going to be, well, a couple things. I mean, you guys know their history. You know, the Truman Commission, later President Truman made his mark as a senator from Missouri by chairing a commission called the Truman Commission that was looking at the Liberty ships, poor manufacturing, poor production, where ships were, you know, so our history is littered not just with these great success stories, but with things that we've learned. We've got 200 years of history of it. I think in the case of the LEO, and if I could leave one thing with you guys here, the proliferated idea is the new idea. It's not only though about LEO, and it's not about or MEO or HEO or whatever. It's going to be probably a collection of those. And that's, by the way, by itself, not enough for resiliency. When you take a holistic look at resiliency, there's limited amount I can say here, but you have to look at deterrence. You have to look at what our signaling is. And you have to look at other parts of resiliency. An example that's been given. You can do software-defined waveforms now very easily on using commercial satellites that are already up there for communications. Well, wouldn't it be an interesting resiliency concept if we had military capability to do our own software-defined comms over a lot of commercial satellites? That'd be interesting. Because then if I'm the other country, I got to take out a lot of things to really affect you. So there's a lot of ways to think about resiliency, but besides just the single architecture, because it's not going to be a single architecture. And people are thinking like this. They are thinking about, you know, one on top of the other on top of the other. The truth of the matter is, when you listen to someone like Andrew Cox, who's done some of the best analysis of this stuff, is that it's just like any other systems of systems problem. You need layered approaches. You need things that are complementary to each other. You can't have single points of failure. But why we talk so much, at least for me, why do I talk so much about proliferated? Because that is something we have not done before, at least recently, other than maybe the NASA examples. But it is not going to be one answer. It will not be one answer. And if you listen to people like Fred and people like Mike, they know that. They're the first ones to say that. Other questions? Yeah.
Sir, Danny Holcomb from the Air Force.
Hey, how you doing?
One of the challenges I was given
in the Air Force from cyber resiliency perspective, my view is now 2.5 years into the job, it's not so much a technology problem, it's a culture problem. I look at the demographics of this room and I see a lot of seasoned professionals, right? I don't see a lot of millennials. How can we try to address that when it seems the focus of the Air Force anyways is, I got to own everything?
Yeah. Well, I think that for whatever reason, space captures kids, you know, and I think we should take advantage of that. When John Hyten, remember when he did the 60 Minutes thing? That captured a lot of people's attention, including, I mean, my daughter saw that and she's like, "Daddy, you work with that guy? Can I meet him?" So there is something about space. NASA's known this, that is really exciting for people. That's why all those people love following SpaceX and all the stuff they're doing. We should turn that to our advantage. I think one of the exciting things as we stand up these new capabilities, SDA, is we can let their imagination go. What did they say? There's high schools now are putting up CubeSats. I think they were, did I hear, Doug, did you say last week, was it a grade school or something put one up? Probably got a better deal than, well, I'm only going to say the name of the contractor, but so the kids are getting excited about it. I think that we should embrace them. And that was one of the purposes of NASA, was to capture the imagination of people, which it did for generations. So I think that we turn that into an advantage for us. You know, whatever you think about the Space Force and all that, it sure got everybody's attention. You know, what's the patch going to be? What's the uniform? You know, that kind of thing. And anyway, that's the only thing I would say. I do find that when you combine the mission with the technology, people get really excited about it. You know, that was really cool when we landed that thing on Near, because you could go home and you could say, "You see that thing in the news? That was where I work." That's really cool to be able to do that. Any final question? Yeah.
I was tempted to say this, but
But I'd like to make a challenge. Mitch Fletcher from Arrowhead System Engineering. I'd like
Okay.
to challenge something that you said.
Sure.
You talked about putting together these systems and settling on interface, you know, and having all the, I would contend that is a bad approach because that's a choke point. Interfaces are trivial. Make those different pieces abstractions so that you can change the abstraction, do the trivial interface thing, and you have continual growth capability without putting the choke points in.
No, you could be right. I mean, I've never heard that before. I thought you were going to come at it and say, no, you have to give it to us and we'll just integrate the whole thing ourselves. So no, that's usually the argument. I heard that. I was on a panel one time where I had to take the open systems position. The person next to me was like, Apple, your iPhone's not open. You know, why are you going? Well, you said something, which if it's true, I'd be thrilled that the interfaces are trivial. Okay, well, okay. Well, we need to get you to teach how trivial it is to our other weapon systems. It's been a real challenge, and yeah, there's a nod right there. So I'd love to hear more about that, because I mean, you may be right. It's something for being so trivial in the DoD, we haven't been able to do it for 30 years. We've got exceptions to it, but if it's you know, so I don't know. Did you want to say something or no? But anyway, thank you. I'd love to hear more about that. I just used to say to people, maybe the bad analogy, it's sort of like, you know, when you're a lot of the neighborhoods we live in were built by a single builder. Mine was built in the 30s and 40s in Maryland, and if the builder had his own proprietary AC plugs, you know, we'd still be either buying from him or the OEM all our appliances. Thankfully, there were standards of interfaces, so we can shop ourselves. It's a trivial example, to use your trivial term, but it's you know, in the DoD, we tend to not do that, and so that's the idea behind it. But if there's a way where you can do this abstraction that makes it even better, that'd be great.
So I got to jump in on that. Fred jumped in on the last panel. I'll jump in on this one.
Yeah.
One of the things we are doing at DARPA right now is exactly what the gentleman just described. So we're actually trying to break the need to have global standards.
Yeah.
Standards are good. Well-defined interfaces are good. Forcing everyone to agree upon one creates a lot of barriers and bottlenecks. So one of the things we're doing right now is build a software tool that allows interface, you know, you use the outlet analogy, interface plug adapters to be generated on the fly. And so the other interesting thing from an industry standpoint is it moves the integration problem from being a program office major prime system integrator to be more of a field maintenance,
Well,
I'll call it a geek squad kind of
That would
system
be
integrator.
great. Yeah, that's great. Thank you. Great comments. Yeah, I mean, if we could do what we're talking about doing without big integrators, that would be wonderful. Okay, I think I'm done here. Okay, thank you very much.
Okay, Sarah, Mike can come up, please. Sarah, Mike. So I'd like to give you an even larger one for MITRE.
Oh, wow.
Because they were our hosts, so if you can.
Where do you want me to go? I'll put this down.
Put down over
Can you
here.
explain why?
Okay. So MITRE has been a tremendous help for many years in supporting the Old Crows. And as everybody knows, the money goes to scholarships. So because of your efforts and the leadership, we thank you, and the workers, everybody. So this is an especially extra large presentation. So get together with, where's the photographer? Is he gone? Oh, there he is. He's back there. He's got a long line. He's got a long line. He's got a long line.
What kind of NEARS rating do you have on that? Okay, thank you.
Thank you, sir.
Thank you.
very much.
Thank you.
Grab your picture.
Oh.
Bill, thanks for your comments, and thanks to everybody that participated this morning. You know, a lot of hard hitting comments. We're gonna kill the requirement system. We're gonna kill the acquisition system. We're gonna kill our major launch providers. And it brings me back to something that Bill opened up with, and that is, How do you stop a group of charging clowns? You go for the jugular, right? So, all right. So a couple of things. So rapid acquisition, going faster, and sometimes you go too fast, right? So this morning, as we went through the introductions, we forgot to introduce Sandra Irwin and Irene Klotz that are here from the press today, because today is a public release. We're live streaming, so you get the opportunity to interact with Irene or Sandra during the breaks. Please take advantage of that. As far as Q&A, it extends to lunches and breaks, right? So we do have to artificially stop things to stay on time. And I'm watching the clock on myself here right now. But Q&A goes all the time. A lot of these folks are here the rest of the day or the rest of the week. So please take advantage of that. Also, we went so fast that we didn't tell Pete that General D.T. Thompson was no longer on the agenda. We reached our 3-star quota pretty quickly. So tomorrow, when we do have General John J.T. Thompson, he is going to incorporate some of the comments that DT would have made as far as the landscape or view from Washington as well. And then one last thing. MITRE, Sandia, AFRL, and Aerospace have contributed videos of things that we're working on. So during the breaks, during lunch and that, there's a scroll of eye candy on different space things that are working. Those engineers, the people that work on those projects are here. So again, avail yourself of the expertise and ask questions about the things that are going. So we've got a lunch break for an hour now. So please return promptly at 12:45.